Hello, Calc BCers. We're going to look at an example today of one of the questions off of the homework. And it's been a while, we need to get it off of the plate. So the problem that we're going to look at is finding the derivative of, or the antiderivative of tangent to the fourth x secant cubed x dx. And we're going to look at doing that from a definite integral standpoint, from the integral from 0 to pi over 4. So when we look at the problem, this is the question that we see right here. So what we're going to do, I know that we have talked about how to integrate secants, and I think we can come up with a way to integrate odd powers of secants. So my strategy here will be to see if we can convert it into that. If this was secant squared, to be honest, if it was secant to an even power, this would be a much easier problem. We'd pull out a factor of secant squared. We'd rewrite the rest of the factors of secant using this trig identity in terms of tangent here. Multiply it by our tangent to the fourth. And then we can do a u sub where u equals tangent and du would be secant squared. But because this is secant cubed, that presents some problems. Taking out the secant squared will still leave us with a factor of secant, and that we can't replace nicely and do a u sub. So the plan then is to rewrite this in terms of secants. So we know sine squared plus cosine squared equals 1. Dividing by cosine squared will give us tangent squared plus 1 equals secant squared. That means this tangent that we have here, tangent squared would be secant squared minus 1. So if we square tangent squared, we'd have tangent to the fourth. So this is tangent squared inside the parentheses squared. That's tangent to the fourth. Now we can expand the secant squared minus 1, the quantity squared, to get what you see here. We can distribute the secant cubed through the parentheses, and that will give us what you see right here. So really, what we need to do now is we need to take a look at how can we find the value of each of those integrals separately. The integral from 0 to pi over 4 of secant. So that's where we'll start. We know that the integral of secant is the natural, well, 1/2 of the natural. We know that the integral of secant up here is the natural log of the absolute value of the secant of x plus the tangent of x between pi over 4 and 0. When we plug in pi over 4, the secant of pi over 4 is square root 2, tangent of pi over 4 is 1. When we plug in 0, the secant of 0 is 1 and the tangent of 0 is 0. So we end up with the natural log of the square root of 2 plus 1 for our first term, and the natural log of 1, which is just 0 for the second term. So this last term here, when we integrate the secant between 0 and pi over 4, we're going to get the natural log of the absolute value of the square root of 2 plus 1. Now, that's going to be helpful because we're really going to use the same concept to find the value of each integral separately. So the value of this integral that we have right here, this secant cubed, is going to rely on what we just did right here. And the idea on all of these will be to pull out an even power, two factors of secant. So we'll have secant squared times secant in this case. Then we'll do our integration by parts. We know that we can integrate secant squared. We can differentiate secant. So what we're going to end up with when we integrate secant cubed from 0 to pi over 4 is u times v minus the integral of v to u. So u and v would be secant and tangent. We can plug in the pi over 4 and the 0 and subtract the difference of those two things. And then we can subtract the integral of secant times tangent squared dx. Now, if we plug pi over 4 in here, we'll get square root of 2, and in here we'll get 1. So this just becomes the square root of 2. If we plug in 0, we're going to get the secant of 0, which is 1, times the tangent of 0, which is 0. So what we have is just square root 2 for our first term. For our second term now, we're going to rewrite this tangent squared in terms of secant squared. So back to our Pythagorean identity, sine squared plus cosine squared equals 1. We can morph that into tangent squared equals secant squared minus 1. So we can take the tangent squared that we have right here and replace it with secant squared minus 1. Distributing through the parentheses then, we'll get the secant cubed for our first term when we multiply secant by secant squared, and secant for our second. Now this is a minus for both of these, so this will stay minus, and when we subtract the negative, that will turn that into a positive. We've already evaluated this thing up here, and we got that. Notice that this and this, there are terms of the integral from 0 to pi over 4 of secant cubed on both sides of this equation that we have here. So we can add this one over to the other side, and we'll have 2 factors of the definite integral from 0 to pi over 4 of secant cubed. And that will equal the square root of 2, which is what we got when we evaluated the uv term, plus we've already evaluated this, and we got natural log of the square root of 2 plus 1. So if 2 times this integral from 0 to pi over 4 of secant cubed is equal to this quantity, then the integral from 0 to pi over 4 of secant cubed is equal to 1/2 of that quantity right there. So that helps us with another piece of our puzzle here. What I mean by that is, as we seek to evaluate this integral, by breaking it up into 3 separate parts, we now know the value of the third definite integral that we have here. So now let's focus our attention on the second one of these 3. We're going to see if we can find the value of the integral from 0 to pi over 4 of secant to the 5th of x dx. So as we look at secant to the 5th, this is going to be the same song, second verse. We're going to take out a factor of secant squared, because we can integrate that when we do integration by parts. We're going to leave ourselves a factor of secant cubed. Differentiating and integrating give us these 2 things. So integration by parts would tell us that the integral of secant to the 5th will be u times v, in this case secant cubed times tangent, minus the integral of v du, which in this case would be 3 times secant cubed times tangent squared. We're going to basically do the same kind of thing that we did when we were working with integrating secant cubed. By the way, we can already plug in the pi over 4 and the 0 and subtract those 2 for the first term here. We'll get the secant of pi over 4, which is square root of 2, cubed. Square root of 2 times square root of 2 times square root of 2 would be 2 radical 2, times the tangent of pi over 4, which is 1. So this, when we plug in pi over 4, we get 2 root 2. When we plug in 0, the tangent of 0 is 0, secant is 1, 1 cubed is 1, times 0 is 0. So our first term here is going to be this 2 root 2 that we have right here. Now with the second part of this, the integral of v du, we're going to replace the tangent squared using the trig identity for that again. We'll replace tangent squared with secant squared minus 1. Distribute the secant cubed through the parentheses, like we did previously. We already know what the value of this integral is. We found this integral up here when we did the integral of secant cubed. So this will be 3 times 1/2 times the square root of 2 plus the natural log of square root of 2 plus 1. And notice that this thing right here is subtracting 3 of the thing that we're trying to solve for. So I'm going to add 3 times the integral from 0 to pi over 4 of secant to the 5th of x dx to both sides. Now I have 4 over here. Here's our 2 root 2 that's coming down. And then this was the answer that we got to the secant cubed when we integrated between 0 and pi over 4. And then I took it times 3. So instead of being 1/2 times this quantity, it's 3/2 times that quantity. Dividing everything by 4 then. I can divide this by 4, I can divide that by 4, and then that will give me, that'll give me this. So I've got 4 radical 2 over 8 plus 3 radical 2 over 8. That gives me 7 radical 2 over 8. And I can distribute the 3/8 through the parentheses here, and I'll get what you see here. All right, so putting the pieces together again. When we go back to here, we now know the value of the integral from 0 to pi over 4 of secant to the 5th. That thing will be what you see right inside the parentheses there. That's all getting multiplied by -2. Okay, we got one more thing we need to figure out. It's secant to the 7th. And as I said in the previous two, this will be done in a similar fashion to the other two that we just did. So secant to the 7th, we're going to break out a factor of secant squared. We can integrate secant squared to get tangent. We can differentiate secant to the 5th to get 5 secant to the 4th times secant tangent. This will simplify then to 5 secant to the 5th tangent times dx. And so now we can do uv from 0 to pi over 4 minus the integral of v du. Just as we did before, we're going to add the multiple of the integral to both sides, in this case 5 times the integral well, we're going to simplify first using the trig identity like we did before. Then we'll get this, then we'll add the 5 times the integral of secant to the 7th. We have 5 times the integral of secant to the 5th, which we already found out the value of this definite integral. We're going to add this over. Now we have 6 of those on this side. Here when we plug in the pi over 4 and the 0 and subtract, the secant of pi over 4 is root 2. Root 2 to the 5th is 4 root 2 times the tangent of pi over 4, which is 1. When we plug in 0, we get 0, so we don't have to worry about that. We add this over. Now we've got 6 of these definite integrals over here. We can divide both sides by 6 now. We can replace the integral from 0 to pi over 4 secant to the 5th with what we found that to be in the previous problem. We can crunch through a lot of algebra here, distributing the 5 over 6 through the parentheses there. And then we can add our common denominators here. So we've got 32 root 2 over 48 plus 35 root 2 over 48. That would give us 67 root 2 over 48 plus the other term, 15 over 48 times the natural log of square root 2 plus 1. So now we found the value of all 3 integrals that we need in order to figure out the value of this. So we've taken our original function, rewritten it in terms of secants only. Then we integrated each of these 3 terms separately. After integrating each of those 3 terms separately, we can combine a lot of these like terms. So I've combined the red and the third terms together here. So we have 67 over 48 plus, this would basically be 24 over 48 times root 2 to get the 91 over 48. Did the same thing with the 15 over 48 here, plus the 24 over 48 here, when we distribute the 1/2. And that would give us the 39 over 48 times the natural log of the square root of 2 plus 1. Distributing the 2 through the parentheses here will make these 4s. We can cancel a 2 out of the top and a 2 out of the bottom, and we'll have factors of 4 in the denominators now. And then we combine our like terms. 91 times the square root of 2 over 48 minus 7 times the square root of 2 over 4. Common denominator of 48, so this will be 84 subtracted from 91 will produce 7 times the square root of 2 over 48. And likewise, 39 over 48 times the natural log of this chunk minus 36 over 48 times the natural log of this chunk will leave us with 3 over 48 times the natural log of the square root of 2 plus 1. And 3 over 48 will reduce to 1/16. And that should give us the value of that definite integral. Hope that helps with the question on the trig assignment. Thanks.